What's up? I left off. I was working on this galaxy map, and I got nearest neighbor and line trace highlighting working, which are the things that I need to finish the rest of the functionality. So today we're going to be working on adding some additional binds to the controller. Right now we have nearest neighbor and line trace targeting. We want to add an origin highlight for the star that you're coming from, which we don't have in place right now, but we'll add it. And then we want to add destination targeting and like snap to view type deals. And then probably like a warp animation. Excuse me, I'm still a little sick, but I'm mostly over it. So just to kind of show what I was talking about, if I start up play here, notice we have a little crosshair and we have this thing started up. So if I aim directly at any of these stars, you might not be able to see it very well, but we have a little box moving around to highlight the star that's selected. I'm not worrying too much about the aesthetics yet because we can trade these out for whatever, but you can see that like I was pointed at this one and now we have it highlighted. You may have also just noticed that when I get closer, whatever star I'm closest to within a certain bounds will have a box around it. And this is just showing that we can properly pull out the nearest neighbors and also what we're pointing at. So these are just like showing the functions that we need, but we need binds to like select target, warp location, things like that. And so, and also we want to bind for like um, move camera on a S curve to a given node that we have highlighted. So today I'm going to be working on that. We have our galaxy blueprint here. So we're just going to duplicate this and we'll call this origin marker, and we're gonna duplicate it again. Call this destination marker. And like I said, we're not doing a ton of work on like the, I'm trying to think of a good word for it. We're not doing a lot of work for the aesthetics of this highlighting. It's enough to know that we are selecting the proper nodes for what's going for like the actions we're taking. So we have our line trace here. Um, what we're basically doing with the line trace is taking the position information from our root and our targeted node, determining like a world of the closest one because these are ordered by distance. So we're just taking the first index. I'm going to actually clean this up a bit so that it makes more sense. We're going to get rid of all of this because we're not using it. We may use it eventually, but we're not using it right now, so get rid of it. All right, so here is our line trace logic. And we'll just do like this. Just gonna organize it a bit. Make it a little bit prettier. All right, center size and location offset are what we're using here, so we can get rid of bounding box composition for now. Gonna actually switch these just because I think it will be a little bit less spaghetti to do it this way, since this is only a single calculation and this involves multiple calculations. Here's line trace marker, move it over here. All right, so we've got the center point of this node plus its size times its location offset, which gives us our relative position in the node. And then we're doing the same thing with the root node. Center times size and offset. Something like this. And then like this. I think this should probably be, like, it doesn't matter right now because our root node is 0, 0, but I think this is supposed to actually be a plus. Okay, so here's our line trace set up. And then nearest neighbor is similar. Move it under for the moment. Move this over. Okay, so do it like this. Just having consistency here. Um, like that. And like this. Once again, we don't need this. 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 This is the same function. Uh-oh, Violet, you okay? You got puke? Alright, hang on, I'm gonna have to clear up some vomit here, I think. It's okay, girl. You do what you gotta do. Okay. She just threw up in her mouth and then ate it back down, so it's okay. And then once again, we're gonna go ahead and break this link, move this over here, plug this into here, just because this is just a single, so we don't need it. Something like this. I think this is right. And then there we go. You okay, girl? All right, great. So there we go. And then we've got select camera forward vector. Okay, this is sampling. This is doing our line trace and our nearest neighbors. There we go. Um, find we don't actually need this. It's not being called. Um, to nearest neighbor and line trace. Process line trace results. Process nearest neighbor results. Beautiful. All right, there we go. So now we need to add some controls. Set destination marker. I'm actually gonna. Okay. All right, so I think we're gonna need to pull coworker in here. What's up, dude? Yeah, I'm doing better. Still got a little cough. Still got some snot, but for the most part, the symptoms are pretty much gone. So, which is good because I got a concert I'm going to tomorrow. So it would have sucked if I was too sick to do it, since we've been planning on it for months. Let's see. So right now we have this Galaxy map pawn. We need to add some control keybinds to it. Bring coworker into this. Okay. We have nearest neighbor and line trace targeting working. Next up, we want to add some more features that we will need to be able to use this as a navigational map. So I got nearest neighbor targeting working, so when you get close to things, we know which node you're closest to, which is important for a lot of stuff. Um, and then I got also line trace functional in the octree, so that if I point at a node, I mean, this is very far away, but if I point close enough to a node, it will highlight it. So today I'm working on being able to add keybinds to set a destination point. So like once you've got one of these nodes highlighted, to be able to lock it in as a destination point with a keybind. And I want another keybind to like basically zoom the camera to whatever you have highlighted as a destination, a keybind to clear the destination, and then the ability to set an origin point. So, like right now, we're just putting boxes around these, but like we can change that later to be whatever kind of graphics we want. Um, so yeah, that's kind of what I'm working on here right now. I want to be able to use this kind of procedural Galaxy Octree as a game navigational map. We have our two unused highlight nodes here, which is why they're not moving around. But eventually one of these would be locked around whatever your origination star is, and the other would be locked around whatever your destination star is. I'm not super worried about the graphics of these like placeholder nodes right now. It's more just like verifying that the logic works, that like all our octree selection functions work and things like that. Uh, ban you. Goodbye. Yeah, I thought it was pretty cool. So now I need to ask some questions of coworkers. So add some more features. Currently, we have a pawn that extends from default pawn that we are using. I need to be able to add some additional keybinds to it that will be responded to within the Galaxy blueprint. We need a keybind for set and clear destination, keybind for focus destination, we will also eventually need the ability to temporarily remove control from the user when the focus keybind is hit so that we can transition the user's location to the focused destination. Finally, we will need a warp to keybind, which will trigger warp sequence between different star systems. Let's see what coworker has to say about this. Yeah, so, or neighboring star system in this case. Like, we have this kind of procedural galaxy that we built, and I've added in the nearest neighbor and line trace targeting functions to the octree that's containing all of this data. Um, so basically, I want to start adding functions to it that can actually allow us to use it as a functional navigation tool between different star systems. And yeah, that's kind of what I'm working on today is adding in new keybinds, um, adding in destination tagging, being able to warp the camera to focus on a thing. Eventually we'll want to add in like the ability to like spawn this thing with an origin point, so like if you went to the galaxy map from within a given star system, we would want to have like your originating star system highlighted. When you select a destination point, we may want to draw like a line trace between the two, um, and then eventually that when you would warp from this view and it would like trigger a little warp animation through this, with you finally ending up at whatever your destination is. And you can kind of see the nearest neighbor stuff popping off as we zoom through here, as well as the line trace. Like if I point directly at a node, it will get line traced and highlighted. And then when you hit one of these points, no, I have procedure, like I have different pieces of this whole puzzle, right? Right now I'm using ChatGPT. I have an entire procedural planet system. I haven't added a proceduralization harness around it yet, but like I can show you that actually. Hang on. I'm not in a hurry. I got all day, so we'll go here. Right now, I just have some height map testing materials assigned to this, but we have various noise formulas to generate various different types of planets. We have a procedural atmosphere with scattering, um, I think I have a lava. This was a lava planet, so hang on. Yeah, so we'll just do. I forget which ocean. I forget which one of these oceans it was. Hang on. Yeah, that ain't the right one. But so I have like the LOD and everything plugged in here. I haven't done the work to set up like the proceduralization harnesses to rig up the material generation with the mesh generation and be able to trade out different mesh generation formulas because we have different noise formulas. We have a lava planet formula, ice planet formula, desert planet formula, terrestrial planet formula for our various noise formulas. But I I haven't done the work to rig up the proceduralization harness for all that yet. But you can spawn in and walk around. Um, but yeah, the idea would be use this with some other assets to basically procedurally generate solar systems based on a seed, and then at the galaxy map level, each of our voxel cores have basically information that can be used as that seed. So each of those stars could generate like a unique star system around itself, and you'd kind of transition between flying around at the star system level, and then if you want to warp between stars, like zooming out to the galaxy map level and picking out your destinations and warping between places and things like that. And right now it'll look a lot better with the actual like properly colored atmosphere, right? Like I was using the one that I had rigged up for the volcanic planet, but this one has this is something more like what you would use for a terrestrial planet, and I don't remember ocean, which freaking ocean material. I have an ocean material that has waves and everything. No, this isn't it. Based on like actual algorithmic. Uh, Gerstner. Yeah, it was this one. So yeah, we have you know procedural waves and things like that. But the idea is right now they're kind of disjointed, but I'm working on the galaxy level like selection stuff to be able to navigate between different procedurally generated star systems, right? It'd be cool if we made an elemental system. Yeah, they can form procedurally. Um, yes, so gas planets I can do kind of with my atmosphere system. I would just change it a little bit. Like I could because my atmosphere is already generating like volumetric clouds as a part of the atmosphere. So if I wanted to change this to work as a gas cloud system, we could adapt as like a gas giant. We could adapt the cloud layer system here. For instance, we could adapt the cloud atmosphere system to have much like a much denser coverage and also some more distortion and different colors and things like that. So like if I were to come down here to cloud density floor, like you already sort of have a gas planet like that, right? You'd have to change colors, but you do have a volumetric kind of pseudo gas giant just by changing the cloud density floor here so that you have full cloud coverage. You wouldn't need the mesh interior for that. So I haven't really done any work on converting this to do gas giants yet, but you could. Let's see what your other questions were. Okay, so yes, you can walk on a planet. In Unreal Engine 5.4 update, they added support for directional gravity. There's like a little bit of work you got to do to monkey with the actual third person character pawn to make it work. But as it stands, I can basically set a center of gravity for the third person character, and it will always fall towards that point. So right now, just in the process of building the stuff, my planet is just at 0, 0, 0, and I have a point set at 0, 0, 0 to be the center of gravity. But what you could do is create, for instance, a collision sphere around each planet. Once the character crosses that sphere, you could set the center of gravity to whatever the center of that sphere is, and then that's how you could have planets in different places. Where once you get close enough to the planet, now you fall towards it, and things like that. You do sort of. You have to, as a part of changing the way the gravity works, you have to change a lot of stuff about the way the camera works. And as by virtue of doing that, you don't run into gimbal lock. Because basically, by default, the camera orientation is set to where to be like locked to the z axis, but we changed that so that the z-axis is basically dynamically derived from your vector towards the center of gravity. So instead of having like so your center of gravity, instead of just falling down on the z-axis, now you fall towards a point, but your up axis for the character is also determined by your vector towards that point, basically. So like all your characters like x, y, and z axes. No, I'll just say we because I'm streaming. So like I'm incorporating you as a part of this process. I'm by my like this is all solo dev stuff. But yeah, so there's actually a tutorial on it. I'm trying to remember. I just searched it. It's like Unreal Engine 5.4 directional gravity. Um, so you basically cool. Yeah, I do it just for fun. Like I enjoy it too. So like the fact like I like talking to people who are interested in it because obviously I'm interested in it too. I wouldn't have uh, gone this far down the rabbit hole. So yeah, the this is all the atmosphere is a Raymark shader. All of these are custom assets that I built. The atmosphere is a Raymark shader that does Raleigh and Mie scattering based on scattering coefficients. The clouds are Raymarked as a part of the atmosphere. The ocean is doing a Gerstner wave composition with depth based integration. So the depth actually has an impact on wave formation, the depth at a given point. So, like, if we go towards the coastline, the waves will sort of bend towards the coastline and also get shallower as we get closer and closer towards the edge. I have different noise formulas. So this is just an example of like a kind of a basic terrestrial planet, but I have noise formulas to do different types of biome planets. So I have a desert, like I said, I have desert, ice, molten, terrestrial, and like a rocky, like cratered, airless type planet. And you can build more with different noise formulas. I'm using Fast Noise 2 library to do my noise calculations, and I'm using a real-time mesh plugin to do my meshing, along with a custom-built quad tree system for basically handling levels of detail, and generating our meshes in real time for the planet. So right now I have this, right? And I kind of have been working at it from two directions. So I've been doing like chatty. I've seen in my game where I want these lizard aliens to shrink the player on a planet they keep on a table, like the player to walk around on the sphere. I don't know what chatty is, but I can tell you where the tutorial I found was like UE 5.4 directional gravity. I think this was it. Yeah, I think this was it. And I don't know what chatty is. But yeah, you could do something with this. And then, like, once you have this set up for your pawn, you basically have to set a center of gravity. No, no, no. It's just it's built into 5.4. So if you're updated to UE 5.4, the directional gravity system is built in. You just have to do some modifications to the pawn. I think you have to do one little bit of C++ changes. That was not like a huge deal. Oh, I'm set. Hang on. So yeah, this is pretty neat. You can do all kinds of stuff with like the atmosphere stuff here. One thing that I thought is really cool is that you can see that we're getting like the Raleigh scattering and the Mie scattering. So when you go into like the sunset zones, you get your sunsets colors automatically derived from your scattering coefficients. So like if I change the color of the planet, your sunset color changes based on the scattering of the scattering color you select for the atmosphere, right? So like if you were scattering more green, then your sunsets become purple. If you were scattering a bunch of red, your sunsets become green and your main sky becomes red, right? So I always really thought this was super cool. And if you're like more like a Earth like scattering would be something maybe like in this range. And that's going to get you your orange sunsets and your blue skies. And there's a lot of little stuff like that in this project because I've been working on it for a while now. Yeah, I was. I mean, I don't have any interactivity. Yeah, yeah, it's not like I'm not trying to go that deep. Besides, like, you don't really. You want some artistic direction over it, right? Like, letting it just be realistic, it actually would probably turn out pretty boring. Um, I want something that's more like stylized. Oh, I see what you're saying. I actually have. Hang on. I have this, which is like a little chat plugin that will overlay. But if I'm doing game dev, I just go back and forth. The Yeah, so like I'm going for more of like a stylized look and feel, so I won't like bright colors, um, a lot of potentially unnatural colors and things like that. So the way that works, right, is I have this voxel octree code that I wrote a while back um, over here, and if we go to the node wrapper, it contains a certain amount of data. It actually it's a struct. No, over here. So each of these nodes contains a voxel core. That core contains a type, which is just an enum. So if I ever want to add more things, I could add different types here. The voxel core data also contains, well, here we can look at it. So here's the node data, right? So we can break this out. So this is the data that each voxel core contains, and we maintain our position of all our elements by basically generating a point cloud and then injecting that into an octree and letting that decompose it into real world positions. And at the same time, it will proceduralize all this data. So some of these are not procedural, like path is its actual path in the octree, index is octree index, depth, center, size. All these are derived data. But things like the seed, the relative scale, temperature, density, composition, these are all proceduralized. So the idea is that we could say inject a bunch of stars into the system, and then we could take, for instance, a seed from our given star and use that to initialize or proceduralize a star system around that star when you go into it, so that when you go into the same system, it will always be the same layout of planets and stuff like that based on the seed. And then likewise, at the star system level, we can inject a bunch of planets and like asteroids and space stations and things like that. And they will all also have these proceduralized values that we can use to basically generate our stuff. And one of those is composition, which is just in our case a linear color. But you could take this color and you could do things like define bands within this color band. It's going to be a lava planet. Within this color band is going to be an ice planet, and then you could do stuff like that, right? Um, that's where I want to go eventually with it. Right now, I'm just kind of working on getting disparate pieces working. Like right now, I just recently got the nearest neighbor and line trace selects working on the galaxy map for the star systems. So, excuse me, I'm getting over COVID, so I have a bunch of congestion and occasional cough. But so I got the nearest neighbor stuff working. So when you actually get close to a node, it will get selected. Or if you're pointing at a node, it will get selected. And so I want to do things like be able to toggle a node as selected as like the it needs a little bit of work because like it's not selecting that one. Oh, I got it. It needs to be very precise when they're far away, which might be a little bit too much, but um, basically I want to be able to like toggle set destinations, clear destinations. I'd like to be able to show some information about the selected element and then do things like press a button and automatically warp the camera on like a curve to be focused on whatever your currently selected destination is. Eventually, you would have a warp button that you'd press and it'd go back into like ship view, and we can scroll you through the galaxy at a rate until you land at whatever your warp destination target is, and then at that point we would load in the star system around that point, load you into different space, snap a picture of this galaxy to use as your skybox for wherever you're at, right? So you could snap like a 360 of this, plop it on your sky sphere for your system you're in, and kind of do the level transition that way. I will not have the planets moving just because it's a pain. Yeah, so the way that works as far as the stars or planets merge, actually, you may have seen it. If we break this out again, so if a point is injected into the same node as a existing point in whatever level of the octree you're injecting or decomposing the point clouds into, it will increment this cluster hit value. And then you can do with that what you will. So we don't ever have 2 points within the same node, but you may have a node that has 5 cluster hits because it was like the point cloud was dense enough to where it tried to inject into that node 5 different times. So if you had a star, you could use that to increase like star magnitude, or if you had a planet, it could be planet magnitude. Those kind of things. Generally speaking, you don't really run into that issue if you're decomposing at like a reasonable depth. Um, and I can show you kind of what's going on there in the construction script here. I have this spiral point cloud function that I wrote to generate like galaxy style spiral point clouds. This outputs a array of positions. We construct a proctree, which is procedural octree, which we define a max depth and a size multiplier here. Um, so the size multiplier is basically the scale of your lowest level node in the tree, and the max depth is how deep the tree can go at its maximum. And then we have these asynchronous methods, or actually this one's synchronous, but if you there's an asynchronous version as well, where we can pass this set of points and a given depth to our octree given a target node and targeted randomization bounds, which this is basically used to randomize the voxel core data, and it will take this point cloud basically and decompose it into our octree, and then it will return us the results, which we can then use to generate our particle system for our galaxy. Um, if you only wanted to render the galaxy, you wouldn't need any of that. But if you want to do things like nearest neighbor highlighting and line traces and actual like knowing where you are in the space, you need the octree to do that stuff, which is why it kind of works the way it does. So like you could generate this particle system just by generating the point cloud and kind of randomizing colors and things like that. But if you want to actually be able to tell where you're at in the particle system and what node you're close to or what node you're looking at that point, you're going to need the octree structure so that you can like do those kind of spatial calculations, right? And like I said, I haven't put any kind of work into the visualization for like the highlighting here. Eventually, these would probably be billboards. Right now, I'm just moving some boxes around so that I can verify that like all the logic is working. Yeah, you can do like gravity's not difficult to make the stars and things rotate or the planets rotate around the star. The difficulty comes when you start talking about combining that with all the rest of the stuff. So like you start talking about combining that with like the player walking around on the planet while it's rotating around the star. You start talking about things like that. It's rough. It gets complicated quickly. Um, so for me, I just want to generate, the points in static space. I don't really care if they're rotating around the planet with like the star with like gravity and things like that. It's just going to be a statically defined system. Component which would be temporary memories issue. The sphere comp would be different size based on the size of the star. Every point inside the sphere started line trace going to yeah. You could definitely do that. I mean, I've actually done some stuff in the past to make the points rotate around a center point. I just decided against using it just because um, it implements it adds a lot of complexity to what I'm doing, that is just like more than I really want to deal with, um, because what I'm doing is already really complex. Yeah, I don't. I mean, I don't need you to do like work or anything like that on your own time. Uh, Maybe, but you start talking about like now you have different reference frames, right? So like the planet has to move along with the player while the player is also affected by the gravity of the planet where the center of gravity is moving. Um, it's I'm sure it's possible. Like everything's possible. It's just not something that I'm really trying to think about right now. Um, and then like yeah, I do have a spaceflight pawn, but I haven't done a ton of work on it. Eventually, I'll get into that once I've got all this kind of. Basically, I want to start working on the spaceflight fund for like inter system travel once I have the proceduralization done to where I can generate a whole galaxy of star systems. So we have the galaxy, we have the ability to generate planets. A star is pretty easy, so we could do that pretty easily. Next would be getting this galaxy map working so that I can determine like targets and destinations, warp animations, and then generating like a star system given a voxel core for a given star. So like once I have this selected, for instance, and we warp to it, once you get right here, we can trigger a load into the galaxy map, which would involve like snapping a picture of the skybox. Um, and the cool thing about this is we can use the system to generate a galaxy map as well. So, like right now, this would be like a galaxy map of stars, right? But I could create another Autry at a different level that has a map of all the galaxies, and that would also become a part of your night sky. So, if you go to a given location, your night sky would be consistent for the location you're in because we can, like, oh, I'm going into this system, for example. Well, we could snap a skybox from our galaxy that we're in, but then we could also have a universe level Octree at a different scale that has all the other galaxies that you can see off in the distance and like some other like gas and things like that. And then if you ever come back to this point, you're going to get the same skybox for this zone. And if you were to go to a point in the center of the galaxy and load into a system here, then you would have a skybox for the center of the galaxy, right? So it's I always thought that was kind of a cool idea that it would be like consistent with your location instead of just like a randomized skybox. And the other thing that's cool about this is because this is just a procedural component, um, we can change things about it and we can proceduralize it, right? We could also, for example, we have generation parameters here. So, like, if I wanted to change the number of arms of the spiral, I can just punch in a number here, and now we have 6 arms instead of 4. If I just wanted 2 arms, now we only have 2 arms of the spiral. Um, and the cool thing, like I was saying, is that you can generate a universe level octree where your voxel core data is used to randomize this type of information, right? So like all your galaxies can be different as well. 13 arms. Now at a certain point, because of our variance, you're just going to have disks unless we decrease the variance, right? Because like with 13 arms, our variance is now wider than our arms are. So it just kind of morphs into a disk. But if I change the XY variance, then we should be able to see some distinct arms. You see what I'm saying? Or like for example, increase the star count. It needs some optimization work as well. The material. So this is being generated as a particle system, and I actually thought it was pretty clever what I ended up with. So the way I ended up doing this in a particle system is I take the size of the node, that's like the size of the star node in the octree, right? So because we're injecting these points into a depth of the octree, each node will have a given size and then a given relative size. So you get size variance between the stars, right? I take each node from the octree at its given size, and I basically multiply the size of the particle billboard by like 1,000. So if our star was like this big, then our actual billboard might be this big. But then in the material for the billboard, we have a gas disk that's like a very low translucency or a very low opacity translucent 3D noise based function to determine the gas surrounding the star, right? And then we have a high opacity center point that's very small in the middle and very bright that we use for the star itself. So the star is at like 100% opacity, very high brightness, whereas the surrounding gas disk is a very low opacity, very low brightness. And what you end up getting is the more stars that overlap in a given area, if we look at the wireframe of the particle system, then your gas clouds start showing through. But where they're less common, you can't really see the gas clouds because it's a very low opacity, right? And that's how I ended up with this effect. And then there's one more thing I do, which is because you have so many stars in the middle of a given galaxy, it would be almost completely opaque if I didn't do some modulation of the opacity of the gas clouds. So, like, as the stars get closer to the middle, their gas clouds actually get more transparent, and that's how that works as far as like the particle system and the material for the galaxy here. And then we put this together with a spiral point cloud function that I just derived from a spiral point cloud function I found on the internet. That's a good tip. So yeah, you could definitely do stuff like that. You could do use that for your arm count or your star count or scaling and things like that. So we have the ability to control the XY variance, which is like your jitter along the plane of the galaxy, as well as the Z variance, which is like your jitter on the, I guess, the Z axis of the galaxy, right? And we can also obviously control. So the gas colors are basically each of these stars has a color that's derived from the octree initialization. So like this might be like a slightly green color, right? Or but they're all different. Or this is a little bit more of like a reddish color. Um, so we have this. Let me find it. Material parameters. We have this stardust intensity. So we basically have galaxy wide global gas colors here, or dust colors. And then this is like the contribution of the individual star colors to their own gas clouds. So if I increase this, then these would be the gas colors derived explicitly from the star colors without regard to like the overall galaxy dust colors. I mean, it'd be pretty close. This is making it like weighted 10 times as strong as our galaxy level dust colors. So we get this as like some nice color variance. And then we get our base color that gives us kind of the look and feel for a given galaxy. So right now we have kind of this synthwave colors, but we could go green. And so like we can randomize all these at spawn time for the galaxy and get different effects, right? um, you don't gotta worry about that, man. I mean, if you want to do a spaceship, that's cool. But like right now, here, hang on. Right now, let me see. Do I have? No, no, no. We're in third person. Okay. Let me see if my. I think it was Spaceflight Pawn 3. No, this isn't the right one. Like right now, and this is just because I like the reason it's pink right now is because I still need some work on the post process effect that's doing the atmosphere and its effects. Like you can see, I haven't done any kind of like integration with this pawn, but we can fly around. We got a little physics based flight controller. So here's my spaceship right now. It's obviously nothing super special, and I think we're gonna crash. Okay. So I have some stuff that's not in the scene right now, which is a speed influence zone. Um, so if I add this into the scene, right, and I set it to be centered. So I don't remember if this is rigged up with the pawn that I currently have, but now this should restrict our speed when we hit the outside of the speed influence zone. So the number you see on the side there is kilometers per second. But the idea is that I can set up one of these speed influence zones to where when you hit like the outside of the atmosphere of the planet, we can suck the player's speed down to whatever speed we want them to be able to travel like in atmosphere. It's been a while since I've used these, so it might not actually work. Yep, it worked. It just slowed us down way too much. But yeah, you get the idea. It's because I have this is the minimum speed limit radius, so we just immediately got sucked down to the lowest possible speed. But yes, you well to be able to like because of the difference in scales, like one of the big problems and challenges of this type of endeavor that I'm undertaking is the difference in scales have a huge impact. So like being able to go fast enough to travel around inside a solar system and go between planets is way too fast to fly around on the surface of a planet. You won't be able to control it. You just smack into the ground, right? So you don't want that. So you have to have a way to basically travel that fast in the areas you need to travel that fast and be able to slow the player down to a manageable speed when you're traveling at a like lower scale, right? And it's the same way for like the galaxy traveling, although I'm probably just going to manage that by having it like basically computer controlled. Like you're not going to fly manually between stars yourself. You would be more like selecting a target from the galaxy map, selecting a begin warp button, and then having and then we can use the galaxy map to construct a warp sequence between the 2 points, and then you warp between the 2 points, you get to the whatever star system that you were warping to. We load in the proceduralized star system, and then we pull you out of warp, and you're there flying around in like the system level navigation. Same thing for like flying between galaxies. You go up a level in the galaxy map, right? And now you see the universe scale. You select a different galaxy, you drill down in that, you select a star, and then you warp from whatever star you're at and whatever galaxy you're in to whatever galaxy you're going to, and we can construct a warp system given the two galaxy, loading the two galaxies in, constructing like a camera transition between the 2 points. We don't have to load any of the other galaxies unless you're gonna like maybe unless your path intersects them or something like that, right? All right, that said, let's start adding in some of these additional control functions that I wanted to add. Okay. Open your custom pawn blueprint, project settings, input, action mappings. Set destination, clear destination, focus destination, warp the destination. Okay. Custom pawn blueprint. Hey, Jinx. No, I don't think this is the way it works anymore. I think we have to create an enhanced input controller. It's been a while since I did this. Um, I don't think that is the way input mapping works. Oh, it's lagging. Yeah, I like complexity too. Like, I don't know if this will ever be a game, so to speak. It's more just like a collection of cool rabbit holes that I thought would be fun to code. You know what I'm saying? I think that's the way input mapping works currently. I think we have to use the Input mapping context and input actions. Input actions. I would like to keep the default on controls that are already there, though. Gonna work. Stop. All right. Good enough. Yeah, I know what you mean. I can be a perfectionist in that way as well, where I definitely have a tendency to tend towards I don't think it's good enough until I've surpassed things that I've seen in AAA games, which means I go down massive rabbit holes that end up taking months and months, uh going from a material based planet system to a mesh based system that you can walk around on was months and months. Going Creating a atmosphere system, a ray marching atmosphere system that's fully volumetric with integrated clouds took quite a while. um Going from just an ocean texture to an actual uh Gerstner wave based simulation. Yep, yep, I know what you mean. But that's what I'm saying. I just do this because I enjoy it. So I don't really care if it takes forever. It's just a fun rabbit hole for me to dive down. I set destination clear. Okay. This is close to what I was expecting. Input action. I set dest. Okay. Okay. Shit. God damn it. My phone just fell on the couch. Hold on. Hold on. Gotta grab it or it'll get lost in there forever. Okay. It's actually my wallet, but that's fine. triggers. Where do I set the keybinds though? Content browser input action. Open each input, configure appropriate. Using keyboard presses, set this boolean, input mapping context, IMC galaxy map controls. Okay. CD map controls. Quickly moves the galaxy map camera to focus current destination. Okay. Close this because it takes up a lot of resources. Focus destination. I warped. Clear destination. Clears the current destination in the galaxy map. Ah, fuck. Okay. Begins the warp sequence from the current origin into the targeted destination galaxy. We'll do this as a hold. Okay. And then we need the IMC galaxy map controls. Okay. Clear can be, I don't know, I just need some set destination. We'll set to T. Or to focus destination set to like G. These are the two, like clear and warp are kind of whatever for now. The two I'd like to get done today are set a destination and focus it and like move it into focus. So let's see. Okay, did that. Handling the pawn, custom pawn blueprint, its input. Okay, I see. So they're gonna have to communicate. Yeah. Okay. All right. So we're gonna have to figure out how to make these communicate between each other because, like, basically, this is gonna need to trigger logic in the blueprint to set a in the galaxy blueprint to set a destination based on whatever its current line trace output is, and then this will need to go to the blueprint, get the location of the current destination, and then transition the pawn to that point. I'm gonna grab my lunch. I'll be right back. Yeah, so I made a couple of Italian subs yesterday, so I just had to grab it from the fridge. See if I can get something on TV in the meantime. Uh, okay. Welcome. Oh man, that's quite a move. That's a big, it's a big reality shift. Yeah. 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 That's like it's a big like Well, I've thought about this before. Like, if you're really unsatisfied, like, I think people tend to fall into patterns where, like, basically, if you don't make a change, you're going to be following the same pattern for pretty much your whole life, and your life becomes like pretty predictable. But if you just move somewhere completely different, then that will upend that, and then you don't know what you're going to get. Personally, I'm reasonably satisfied with where I'm at, so like I don't feel the need to do that. But like I could definitely see like if I was ever like very unsatisfied, I would consider making a big change like that. Yeah, I mean it's probably like that to some degree or another, no matter where you go. Mm-hmm. I live in the states in Connecticut, but I've been to a few countries, but never for like any extremely extended amounts of time or anything like that. I mean, America's sort of like that too, just kind of a hodgepodge. I mean, true to a certain degree. Burgers, hamburgers, and barbecue. I mean, Australia has its deadly wildlife. Mm, I see. I mean, how else are you going to repel the kangaroos, though? Yeah, sort of like deer in the States, except for probably I would rather go against a deer than a kangaroo, I think. Yeah, I think so. Oh, delicious. I got my Italian sub recipe on lockdown. Okay, let's see. Should they implement? I think generally, for the most part, wildlife is like that. Like none of that wildlife usually wants to fuck with humans, or it usually doesn't want to fuck with anything it can't eat, basically, and will only do so out of desperation most of the time. Now I'm going to say 100% of the time, but like most of the time, even like predatory, venomous, like dangerous things don't want to fuck with something if they're not planning on eating it. Sure. Yeah, maybe like fleeing something else upon triggering. That's funny. Upon triggering the focus destination, it need to somehow be currently selected heat map. We can plot. Why is this lagging so much? All right, come on. I don't know what's going on with ChatGPT here. Behaving strangely. Maybe it's time for it to overthrow humanity. Ah, interesting. Okay, so yeah, I've used Copilot some, but I just it's whatever. It doesn't seem to be much different than just querying ChatGPT directly. All right, so assuming our length is greater than 0, GPT 4.0 isn't paid. GPT 4 might still be paid. I don't know. All right, so if we have an actor of type BP Galaxy, no. We want a reference. I go to execute get, it says it's get copy. Is that going to work? Reference? Doesn't seem like it would. Yeah, this is not going to work. don't know why this is shitting the bed. I mean, right now maybe it would be better. I go to try and get the first element of the array. It says a it's a copy. Seems like that wouldn't work as a reference. Seems like that would. Ah, okay, that makes sense. So it's so it's an array of references, and we're getting a copy of the reference, which actually makes sense. Okay, cool. So then in our galaxy map, something like that. All right, great. And then okay, next BP Galaxy event graph. The destination. World scale, world location. Okay. Okay. There we go. Beautiful. Okay, so upon receiving this event, we're going to set the world scale 3D in the world location of the destination marker to be equal to the nearest line trace marker. That should be good enough for now. And then inside our galaxy map pawn, set destination is triggered. We can take validated get. I think set destination was T. So let's test it. So we'll do this. We hit T. No, it didn't work. Fuck. All right, hold up. Ah. Um. Find input. How do I bind the input mapping context to the pawn? Okay, we have that. Yep. We already did that. Fin graph, add the input, get player controller. All right, let's see if that worked. Nope. Okay. So didn't trigger. Seems correct. Hmm. Interesting. Set destination. Okay, so I added a custom event to my Galaxy blueprint named set destination. I invoke it inside the set destination action handler in the pawn. I can see the pawns action getting triggered, but I never break point into the event inside the galaxy blueprint. Issue communication issues, blah blah blah. Make sure you have a valid reference. Get all actors, reference, ensure it's successfully stored. The reference is not null. I'm doing that. Chroma, add a print string. It's valid. Yeah, we rig pointed. It was valid. Make sure you call the event. Case sensitive. Move this over here. Hey, wait, it's working. What? Why did it just? Why did it just start working? I'm so confused. All right, so now we have destination. What? Can't go to it. Hang on. Okay, it's working now. Okay, it was the kill Z, I think. Okay, so we can set a destination. Next, we need to be able to focus a destination. Okay, I got set destination working. Next, I need a function call Currently set destination. I think returning just position would probably be fine. Okay, easy enough. Function get destination, get current. Just get destination is fine. Okay. Um, vector. World location. Okay, great. This should be public. It is. All right, so now copy this validated get. Get destination. All right, now we need a little bit of work here. To do. Unbind all inputs, transition on to destination location. Path, stop enough space to be able to view. Okay. Okay, I have that done. Next up, in the on invocation of focus focus destination, I want to unbind all user inputs so they can no longer control the pawn. Then we want to animate a transition. Transition as follows. One, on turn to face. Okay. One. The current destination is fetched from the galaxy blueprint. Two. One is animated to transition to perfectly face the returned destination location. Three, a pawn animated along animated using a curve along the path to the destination location. Path composed of its current location to the destination location. Stopping just short of the destination. Stopping short some set amount of distance from the destination position. 4. User control is rebound so that the user can control the pawn. Get player control or disable input. Okay, easy. Nice. Okay, perfect. Okay. Self reference to self. Look at okay. This. Where's my get look at? Fuck. Um there it is. Destinations here. Timeline flow track, smoothly interpolate or interrupt set actual rotation. Timeline flow track, R interp 2 or set actor rotation within the timeline. Okay, I see. Track. That should be fine for this one. Okay, and now back out here. Okay, great. So instead of this one, we'll use the one we just made. Update this, rotation track, delta. Um, let's go one step at a time. Rotation, I have a timeline. Rotate using a curve over 1 second. The timeline with a float track that will go from 0 to 1 following an S curve over 1 second. How do I use the output of this node with an inter 2 node to properly animate Pawn's rotation? Okay, yep. Okay, rotation. Fine look at rotation. Yep, we did that. Start position. Yep, we did that. Timelines update. Use it. Gradually interpolate the pawn's rotation with the current rotation. Target rotation. Get the current rotation. Use blah blah blah. Target delta time. World delta seconds. Get the time between frames and interrupt speed. Timeline. Okay, got it. Get world delta seconds. There it is. Okay. Okay. So let's test that. Disable input. Play, and when it's finished, we'll enable input. All right, let's give that a shot. So now we should be able to set up a target destination, and when we press this, it should rotate us. All right, so we have our target destination. If I look at a different point, okay, it stays, and then, oh wait, hang on, we don't have a binding for this. Focus destination, G. Okay. Okay, so it's disabling, enabling. Mm, it's not disabling it though, and it's not rotating the camera. Okay, so I'm gonna have to figure this out. Actually, hmm, hey, wait. It stopped it for a second. Okay. That's encouraging. So it's actually so I press this, but if I G, it stops it until okay, perfect, great. So maybe play your camera. That ain't it. Okay, so disabling and enabling The user input is working, but when we invoke rotation on, it does not seem to be changing the camera direction. This pawn arrived from the default loading pawn movement class. There is no camera component. Again, this is default. Player controller, set control rotation. There it is. Control. Like this, perhaps? Ah, sort of. Except for not quite. Okay, that sort of works, but enter to is not fully pointing target location by the end of our timeline. In other words, at a timeline value of 1, we are not fully target location. No, we don't want to do that. Do that because there would be a sudden jump. Okay, that's what we want. Um, I'm gonna have to figure out a way to make it like more or less precise as it goes out further away. Okay. Set target location. Rotation. This might have something to do with it. Come on. Okay. Pick a point. Okay. Targeted. That didn't work. Oh. And you're banned. Goodbye. Let's close. It was a bot. It was like a view bot spammer. I just instantly ban anybody trying to advertise like view botting services and things like that. Mm-hmm. Oh, derp. Aha. Success. Awesome. All right, so stage one done. I might be able to do that. It works. If it works, I guess there's no need to try the RInterp 2 again. All right, so now we're going to need a second timeline. We should probably set this for one time so that we're not recalculating the lookout rotation on every frame. Yeah, it automatically clears out their messages when you ban them, but I just fucking they're all over the place. They always come in. I just instantly ban them. It's like I'm not really doing this for views. I just do this because like occasionally I can chat with people while I'm working, and also it gives me an easy way to store the videos of my progress as like a sort of a pseudo devlog. But I'm not trying to become like the next big Twitch streamer or anything like that. Okay, so we have one of our animations right here. The next timeline. Add a float track. Okay, I have the rotation working properly. Next, we will need another timeline to manage location shifts. Um, I have an acceleration curve I have been using that goes, that is a basic S curve going 0 to 1 value over 0 to 1 time. If I want the time to take longer than that, can I use same curve in the timeline but stretch to fit however long I want the animation to take? Yeah, like I'm just like a regular software dev by day, so I'm not really relying on this for like income or anything. I'm just doing it for fun. 0 1, change the length of timeline, extend the timeline however you want. This curve will not be stretched across the mean move, take longer to complete the curve. So wait, what? Okay, I didn't know that. No, that's not how it works. Um, Based on what I can tell from the timeline graph, if I change the length to say 5, it looks like the curve still maxes out at 1. It's not going to work like that. I can tell from the graph that it's the GPT's wrong here. Because, like, look, if I do 5, we can see that we're at 1 at 1 second. Pretty sure it isn't working that way. I look at the timeline and change it to 5 seconds. It shows the curve still maxing out at the end of second one, with the remaining 4 seconds all outputting the maxed out one value. All right, we'll just do 1 second for now. We can come back and make another curve. 1 second is probably about right for what we're doing anyway. So back over here to the galaxy pawn event graph. Okay, so when this is finished, I'm going to play this one from start. Um, Wait, hang on. Do this so that we're not constantly recalculating it. Okay, next. World location. Hang on. World location. Tar location. Um, so I'm actually between, well, I'm not exactly between jobs right now. I have a job that I'll be starting in October as a team lead for a government application for like immigration processing of like immigration stuff. Um, but yeah, most of my jobs have been like DoD stuff, Department of Defense. So like I did work for the Air Force and the Marine Corps and some other stuff. So like I mean it's been a pretty big variety of stuff. Like I've done some web stuff, I've done some embedded stuff, some like situational awareness stuff for the Air Force. Big grab bag of stuff over the course of about 15 years. Uh, okay, set world location, lerp, vector. Let's try it. All right, now we just have to stop a little bit short. It should not be a problem. So, so we just have to change the target location here to stop short. Yeah, some of them were interesting, some of them were not, but they all pay the bills pretty much, and that's fine. You know, like I don't have to be incredibly. It doesn't. They don't all have to be incredibly engaging. Like some of them were cool. Like I did some custom network discovery stuff for the Marine Corps, which was really cool with some asynchronous network discovery algorithms where you basically manually construct half of a ping packet and fire out a shitload of them over an IP range asynchronously, and then build a map of devices as they come back. And then we had a client running on the devices that we had control over. So the first step was basically finding any device within an IP range and building a map that way. And then you would take each of those targeted points once you found that map and send basically like a check to our own API to see if we have a client running on that device, and then it would come back and you would say like if it responded, then we know that we have a client running on that device, and then all of a sudden you can do all kinds of stuff, basically remote administrative type stuff. I also did some like threat awareness overlay stuff using Google Earth. Some of it was cool, and then some of it was like, oh, it's a a glorified web app. Okay, so our target location needs to be changed a little bit. Okay, I have it animating to the targeted location. We need to change it just a bit. Oops. Rather than going all the way to the targeted location along line, need to stop some arbitrary distance before we reach the targeted destination. So, for example, if we are at 000 and we want to move to 1000 instead we would want to calculate our target destination as 900 0. We want this distance to be configurable. Yeah, and Western countries care a lot about degrees too. I mean, like, it's definitely an uphill battle. Especially, like, I don't know, man. Like, the job market's rough right now too. At least it was when I was looking. It took me. I have 15 years experience. It took me longer to get a job this time than it's taken me before in the past. It took me like about 3 months. Um, but I mean, persistence, having, like you said, having that portfolio, knowing your shit is good. Yeah, if you, I mean, like, it's rough without a degree for sure. You basically are, you have to be like above and beyond basically without a degree. You know what I'm saying? Like somebody else may be able to just say like, ah, I got this. Yeah, some of them don't. Some of them don't. Um, it's definitely more challenging because it's like I'm trying to think of a good way to put it. Like you have to like go much further above and beyond to prove yourself over somebody who does have it, right? Because like a lot of times you could get in an entry level position as somebody who does have a degree. You don't necessarily have to do crazy good in the interview. You don't necessarily need like a portfolio of work or anything like that. It's just like they'll like basically credit you by having that degree, right? But without it, they're gonna really want like proof that you know your shit, you know? Yeah, and for sure. And like if you have impressive things, like it doesn't even have to be related to what you're applying for. Like I showed this project to people I was applying for. I'm just like I do this in my spare time for fun. Like here is this is this more or less complicated than what you're doing? Because if it's more complicated, then I'll probably be able to do whatever you need. That type of stuff. And some people will respond to that and some people won't. But having something, if you don't have a degree, definitely having something you can show off that's like hard or complicated or like technically impressive is almost a necessity because you're not going to get that benefit of the doubt that you would get if you had a degree. Um, and if you do get a job and you make some money, you may consider um, going back to school and getting that degree as well eventually. It's like it it doesn't guarantee a job, but it gives you that benefit of the doubt, kind of. Subtract. Okay, I think I get it here. So we're gonna go subtract, normalize. No, 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 no. It's our direction. Multiply. This is the chunk we want to lop off the end. Distance. Sure. I don't know how you're gonna show it to me though. If you got a way to show it, that's cool. Target location minus point location. I think I did it in reverse. Yeah. Target location minus pawn multiplication, normalize, multiply. Calculate the. Okay, okay, I see, I see, I see. So then we just calculate the full vector. Um, Subtract, multiply. Operator doom. All right, 1 second. Yeah, dude, that's neat. You just threw that together in what, Blender?
No. This is ZRush. Can you hear me?
I'm gonna. Yeah, there you go. Yeah, I can. I'm afraid that it's gonna echo though. All right, so let's test this animation. Find a point. Okay, target. Oh, that's okay. That's definitely not right. Okay, something is wrong with the calculations here. Also, tool is the shit. I've been using. I've been doing like. Oh, it's in ZBrush. I see. I've been doing like AI generated music to listen to on streams for copyright free reasons. Making playlists occasionally. It's kind of fun to fuck around with. Okay, so our calculations are definitely wrong. Let's see. Um, World location minus. Okay, let's try this. Maybe I had it right the first time. I love metal. I'm actually. Have you ever heard of the bands Unleash the Archers or Powerwolf? Oh no, that's wrong. Because I'm going to see them tomorrow, and then a little bit later this year, I'm going to go see Iron Maiden. Mm, definitely. All right, yeah, definitely check out Unleash the Archers. They're the shit, dude. It's like a prog metal. It's got female lead singer that's like really, really good, and then they do like Hang on. Yeah, I know, right? Like, I figured, I saw that they were touring near us, and I was like, well, I would have loved to see them in their prime, but I wasn't really like going to see concerts when they were in their prime. So maybe I can see them at least once before they die. Let me see. Hang on. I'm not gonna because I'll get copyright struck, but like I can do this and link one of their songs. Yeah, yeah. I mean, I don't know if they'll be good or not, as old as they are, but I figured it was worth a shot, right? Because they're like legendary band. True, true. Um, it's more like I also upload these to YouTube and they can be taken down. Yeah, it does. I mean, it's just raw stream dumps. I have like an idea that eventually might want to get into video editing and make some more like produced content. So I just want like a record of everything. So I just export it to YouTube and then I have it and I don't have to store it on my own hard drive. You know what I'm saying? But I'll check them out. I'll check them out. I the Yeah, I'm going to see them in Powerwolf. Powerwolf is like they're super cheesy, but it's fun. They're like a gothic Catholic werewolf themed metal band. Why is it okay? So I definitely have something wrong with the navigational stuff here. Could I not just use? It seems like we could use the. Could we not just reuse the look at rotation? Get forward factor. Okay, perfect. Um, Seems like that would be a lot easier. Yeah, I don't really like have a consistent like upload schedule or like what I'm doing. Like today I'm working on this. I I generally I play a lot of like Magic the Gathering, 'cause I'm pretty good at that. Lately I've been playing some WoW. I just kind of do whatever. The fuck? Let's do this. Not subtracting anything. Yeah, so that's not correct. Because if I just take the destination location and plug it in here, it works fine. I just need it to stop like here instead of here. My name's Sam. Yeah, I like Ghost too. Haven't heard Windrose or Bleeding Through, so I have to check them. But I do like Ghost. That's another one I'd like to see if I found a tour date near me. I'm kind of close to New York City, so we usually end up going to see bands there. Later, dude. Oh, you know what? We could just do it with the curve. Oh, stop. You just have it go 98% of the way. Yeah, there we go. It's not perfect because we would rather this be like a statically defined distance rather than using it as like a percentage. Because what this is effectively doing is making us travel 99% of the distance to whatever our target is, which means if we're closer to it, we're going to end up closer to the end point, and if we're further away, we're going to end up further away. So like we're pretty close to this one, so I'll target it, warp to it, and then we get very close to it. But if I go to a further away point, maybe, maybe. No, no, I'm still on this one. Yeah, see, like right now, I'm up in it, up inside it because I started the warp from close by. So yeah, that's not gonna work, but it does work as a proof of concept. Pretty neat. Yeah, I actually saw, um, like I said, we're somewhat close to New York City, so we get to see quite a few bands there. We went and saw, oh gosh, I've seen Camelot, Dragon Force. Dragon Force show was actually awesome. I didn't know what to expect because their music is so ridiculous. Um, but like they killed it. It was one of the more impressive ones actually. I wasn't sure if they were going to be able to do it live, you know, but they absolutely did. Maybe I need more iterations on my line trace. More iterations or a higher depth. Raising the depth is like doubling the iterations because you're increasing the chunk size. Let's increase it again. So basically, because we generate the locations by injecting a normalized point cloud into an octree, we have the ability to interact um, with the octree in different ways. And they give us the ability to do things like forward line traces within a certain bounds, find nearest neighbors within certain bounds, and maintain like spatial relationships of the positional data. Still too far, huh? Fly all the way to the other side of the galaxy and then hit G. Takes us right back. Pretty cool. Um, so it's still frustrating that I have to do it with a curve and not a precise calculation. Sure, I can take a look. You want to pull it up on your stream? Show me something you got that's cool. Yep. Goodbye. Yeah, you want me to type on your stream? I'm just gonna keep poking at this while you're pulling up some stuff.
The code will
Ah, I think it was locked up.
make it so you can
Let me turn you up,
I can drop the weapons
and let me turn me down.
and then pick them back up. Okay. Next thing you might want to see. designated inventory contains the item. And so if the item is whatever, I will check it with this.
Yeah, I don't know if you can still hear me, but it is interesting. Like this is basically like a completely different path. Like I said, I've built a bunch of procedural assets, but almost no gameplay, just like a little physics flight model. Um,
So I don't have to write this for each inventory.
yeah, but yeah, are you familiar with octree or quadtree data structures? Okay, great. Um, yeah, so most of my procedural stuff is built around octree slash quadtree data structures. So like I can kind of
Yeah.
so the idea of this is like if you know the idea of like a tree in computer science is a node that can contain copies of itself. So a node may have child nodes, right? And those child nodes may also have child nodes. And so it's like a recursive data structure. So there's some explicit versions of it called a quad and octree, which I'll just show a quad tree, where basically they're used for decomposing space. So a quad tree can decompose 2D space, and basically, if your root node is the big square, then each of its children would be one of these squares, and then you could then subdivide any of those children into children, and you can do this recursively as deep as you want, right? So, and then an octree is the same thing, but instead of a 2D plane, you're doing it in 3 dimensions. So instead of dividing into instead of dividing into 4 nodes, you're dividing into 8 nodes per child because you're basically subdividing a cube in half. And bear with my bad paint skills. But and then each of these could then be subdivided further. So the idea of doing that is it gives you it's a spatial acceleration structure. So it makes operations upon objects that you have in that tree much faster than brute forcing it because instead of having to check like every coordinate space to see if an object's there in your data structure, you can go to a node and you can see, oh, like this node here is only subdivided to a certain level, so I know that there's nothing in that node. Whereas this node here is subdivided to a much higher level, so I know that there may be something here. And then you can check. It also makes like pulling out leaf nodes much faster because instead of having to check everything, you just have to say, oh, I'm interested in nodes at depth 8 in the tree. So check any nodes that have children at depth 8, and then you're going to check their voxel core data and see if there's an element of a given like enum type occupying that space. And if there is, then we know that there's an object there. So just to kind of demonstrate, this would be the C++ side of my project, which is not as well organized as yours. But if I come up here, we can see that we have like a basically a binary indexing for our different tree nodes in the octree. And we can determine where a node falls in the octree based on its position. So if I take, if I go back over here to this little diagram I was drawing, if I assume that the center of my tree is 0, 0, 0, and I take any arbitrary point within the space of my tree, let's say 100, 100, 100, you can determine which of these quadrants is going to fall into based on its relationship to the nodes, the center of the node that is currently being inserted into. So if I'm inserting it into the root node and the root node center is 0, 0, 0 and it's 100, 100, 100, then I know that it's further to the right than the center, it's above the center, and it's further along the y-axis from the center, right? So I know that it's going to fall into like the positive. If I could draw on the thing, I don't know what's going on here. So I know it's going to fall into the positive 1, 1, 1 index child in my root node. But the fun part is we can take that same point and we can take this node and we can subdivide that node further, and we can do this to an arbitrary depth. So let's say we want to do it to depth 18. So we can keep drilling down and subdividing nodes until we get to level 18, and then we can insert an activated node at whatever index it falls into in that. And it seems like a lot of work, but what that actually ends up doing is it's a big part of the reason why we can easily pick out like nearest neighbors and things like that, because we know where the player is and we can go up to a certain level and examine all the nodes directly near the player, and we can then find all of their children of a certain type, all of their descendants of a type, in this case stars, and then we can rank those based on distance and return that list back to the player. So that's why when I get close to this node, it can pop up, even though this is just a particle system, and normally you wouldn't be able to do that with just a particle system, right? Because not only is this a particle system, but all of this data exists in an octree data structure that we can query with different ways. And then the other way that we're doing it right now is a line trace. So that's why when I look at a node, I can highlight it because I'm doing an actual line trace here, and then we can, warp up to it. So that's how the galaxy works. We start with a point cloud. So I just generate like where'd it go? Here we go. I wrote this point cloud function based on basically the formula for a spiral, right? So I generate a bunch of points along the spiral and then I jitter them by some amount, which is controlled by, the parameters going into this. And then I can take this point cloud here and I can take these positions. So these positions would be between -1 and 1. So they're normalized between -1 and 1. So on the X, Y, and Z axes, they will always be between -1 and 1 on the output here. But I can then inject that normalized cloud into my octree at a given point from a given node. So we're feeding it the root node as its targeted node, and a set of points and a depth. And because we know what, because of our definition of the tree here, where we say our base unit is going to be 20, so the smallest node in the tree is going to be size 20, and our depth is going to be 20, so our maximum depth in the tree is going to be 20. What it actually turns out to be is it's actually 20 times 2 to the 20th. And so this is our ending scale for the tree. And if we inject those points at 0 to 1 or -1 to 1 into the root node, then we end up with points decomposed in the root node's coordinate space of this scale. And what this lets me do is potentially represent much larger coordinate scales than you can actually store in double precision by virtue of it being in the tree. And you can convert them as you need them as you get closer to them. So you don't have to worry about like basically floating point precision errors when you're dealing with like these very large structures. So like obviously this is smaller than an actual galaxy would be, right? But the idea here is that we can treat things in like different relative spaces. So even though I'm decomposing this to that scale here, you could have a much deeper octree, and you could store galaxies at a much higher level in the octree, and you can treat those scales independently of each other. So, like if I select out the galaxies, maybe I have a galaxy map, I have them in a similar scale to the galaxy map, but we move it at a different rate because it's at a different depth in the octree. So that's kind of how this galaxy is generated. And the cool thing about that is it gives us access to all the to a very efficient way to process all that positional data. And then the other thing that we're doing with the Planet Sim stuff is that's using an array of quad trees. So if you think about, excuse me, if I go back to Paint and I blank this out, if you think about a sphere, you can actually create a sphere from a cube. And what you can basically do is if we generate meshes on each of these cube faces and then we normalize the points on each face, it will basically shrink wrap this cube onto the sphere. And then you can multiply it by whatever radius you want the sphere to be. So each of these faces in the planet sim is managed by a single quad tree. So our actual planet is a composition of 6 quad trees. And then we basically run a noise formula. Fast noise. Hang on. So we basically can run a noise formula on those decomposed mesh points and generate our terrain for our sphere. So like we shrink wrap all the points onto the unit sphere, and then we offset those points by some percentage of the radius based on a noise formula. So if I open up one of these, this is just the noise library. I'll go ahead and get my most recent terrestrial formula here. Correct. And the cool thing about it is even though we don't necessarily need to show them in at a scale true to life where we would lose all our precision, we preserve the relationship between scales within the fact that they're inside of the octree, right? So a galaxy node at a higher level of the octree can have star nodes at a lower level of its children of that node. So that galaxy node may have 6,000 children that are its star nodes, and each of those stars can have children that are like the planets and rocks and shit orbiting that star. And all of those positional relationships are preserved in scale in the octree, and we can basically monkey with the scales at that point based on what level of the octree we're looking at, while like a struct and a struct. It's a sort of, so I use a struct for the node data. So like when you fill out a node, it gets a struct, but the octree itself is a recursive structure or a recursive object. So it's like and then each node would have something like and in that data, it has things like ID, path. This would be its path through the tree. So, like, if you think about our tree nodes, each child could have an index, right? So we have in the octree, we have 0 through 7 as child indices. So if your root is 0, then your path might be 0, and then we're in child 1, and then we're in child 5, and then we're in child 3, then we're in child 7, etc., until you get to whatever node you're actually in. And you can use this path to backtrack your way to that node through the tree in a in log in time, so you don't have to iterate every node in the tree. You just know from this that okay, we're at the root node, we're at child 1, we're at child 5, we're at child 3, we're at child 7, and then makes it very fast to access that positional data without having to like crawl a bunch of values or loop through anything, right? We literally just index straight into the children until we hit the node that we're talking about. But then you would also have things like node center, which is like its world space, um, node scale, which would be like its size that I was showing you the formula earlier. It's like 2 to the whatever power times your base scale. So whatever depth you're at, you can calculate what size. You can have a relative offset. So if you're inserting something into that node, you may not want it directly in the center of the node. So you can have a normalized offset between -1, 1, 1, and 1, 1, 1, that will offset you so that you know, like if I know where the node center is in world space, I know what the node scale is, and I know what the relative offset for the node is, then I know what the object stored in that node's center point is, because I can multiply this relative offset by the scale and add it to the node center to get like a precise location for that point. Um, you've also got relative scale. So you've got your node scale. This is the actual like size of your bounding box of the node. But then you could have relative scale, which is if you want your object, which I use for the stars, for instance, to give them different scales based on just randomization values. Um, you have your relative scale that can say, oh, this object in this node is this percentage of the node size. Um, we also store a randomized composition value, which is a color value. And this is what is used to determine like the color of the stars. If you're doing a planet, you could use this for randomization parameters for the planet or the atmosphere and things like that. So this is kind of how the octree works. And then this is a noise editor, basically, where I can layer noise compositions. So I'm going to pull this up. And this is how it's not working for some reason. But this is basically how I come up with a noise formula for the planet generation. Which if I come down here, planet actor. So we can see here I'm initializing a noise generator for each face, and then basically a root node for 6 different quad trees. And this is how the planet works. And then at the same time as this, we're doing things like on a timer. Going back to the planet objects and popping it into wireframe. So on a timer, I'm checking the camera position against the centroids of the quad tree nodes, right? So as we calculate the terrain, we can calculate a centroid point, which is just the average of all the vertices of that node, and we have a basically like a LOD function that calculates how far away from that we are, and will automatically cause the nodes to split or merge based on how far away from that portion of the surface we are. And what that lets us do is every time a node splits, if I go to a quad tree node here, the biggest function in this is one big procedural function right here. generate mesh data. So every time the node splits, it generates a number of vertices, a static number of vertices, like basically a grid for that node. And then this is the logic that goes through, uses the noise function to calculate an offset, and basically reconstructs a bunch of mesh data, which gets fed into this plugin that I'm running called Real Time Mesh Plugin, which is just, it's sort of similar to the procedural mesh built in Unreal Engine asset. And so we basically build our mesh data manually based on all of that, and then it gets plugged into this node. And so, just by virtue of them splitting, when they split, they kick off an asynchronous method to call this generate mesh data. And when this finishes generating its data, it returns to the game thread and actually renders the it calls this create section group, which is returning the game thread and actually rendering the mesh data that is generated. So this is like a good way to kind of visualize the quad trees in real time. So if I come back out to my mesh planet actor here and I get rid of this, um, we can actually change the settings. So right here you see I have a min node depth of 4. So that means that we're automatically subdividing to 4 nodes. But if I set this to 2 or even 1, then if I go as far away as possible, you can see that at our furthest distance, we only have the root node, right? So,
Sam, can you hear me?
yes, I can. Yeah, sorry. I was just checking chat real quick. So like here, they're at root node, so you can see how many vertices we have on a given node. But as we go in,
Oh, I want to show an artist
sure,
work and
sure.
see what she's doing. But I think the it's like 2:30 for me. It can only take in so much information, but it's super fascinating how you can
Yeah, all good, dude.
reconstruct procedural integration and how it can relate to one another. And I can see from what you're doing, there's huge potential in it in lots of areas. It's not just the one thing. It's not just planets and stars, but it can be the texture of the sphere and so on.
Yep, it's pretty neat. But yeah, you can like do whatever you need to do, man. I like talking about this stuff. I'm actually probably about to wrap up anyway because my goal today was to get to where it would warp um, to my selected destination points, and I've got that working.
Yeah, it's cool. I enjoy it.
I'm probably
I'll
gonna play
I'll
some
drop you the
Magic
link
actually.
whenever you're on.
So yeah.
Sweet. Did you want to send me your Discord in a whisper or something, and then I can arrange to send you that spaceship? Because I really love to send it to you. At least it, like, if you get bored of it, you can always update it or whatever. But it's
Um.
got to be better than a ball
Let
a line or.
me yeah, let me I don't have a Discord. Let me how big is it? Could you email it? Um
I'll give it an export and see file. Where's the export?
Transfer. Generate the link. Share content. Echo 3D. Yeah, see, like everybody's using Perforce and like I don't. That's not gonna work. But I do appreciate it.
Okay, so it is 24.8 megabytes.
Um,
24.8 megabytes.
Trying to think of a good way to transfer that. Shit, I've got some stuff I gotta do. Okay. Um, you might be able to Google Drive it to me via Gmail.
There's a couple um, free methods.
You can try sending it via Gmail. If that doesn't work, it's not a big deal. I looks like I've got some paperwork to fill out.
Is it under 24 minutes?
But yeah, I'm gonna let you go. I actually got something I gotta do that I just found in my emails. So later. But nice talking with you. Let me know.
I can try and compress it later if you want. I can probably compress it to email size.
Sure, we'll give it a shot. All right. Well, I appreciate it, man. Nice talking with you. Later.